Welcome to qnawire.
Okay, for what values of a and b is 2 comma 2.5 an inflection point of the curve x squared y plus ax plus by? And so in order to find the function that satisfies the a and b that satisfies where inflection point of 2 comma 2.5 occurs, um, we have to first of all, let's just start off with isolating y in this case. So we have x squared y plus ax plus by. So I'm gonna move the ax over to the other side, so it'll be negative ax, and then I can pull out y. So this will be y x squared plus b equals negative ax, and then y. Oops, sorry about that. And then this will give us y is equal to negative ax over x squared plus b. And then now we can take the derivative, since we want to get to the second derivative, because we know that an inflection point means that the second derivative is equal to 0. So we know that I actually did this earlier, so it comes out to be ax squared minus ba over x squared plus b, and this is going to be squared. And then the second derivative, y double prime, is equal to 2ax times 3b minus x squared all over x squared plus b, and this is going to be cubed. So now what we are going to do is we know we have these two values, so we're going to plug them into our original function, which is this function, to see so we can use that later on to find the values of a and b, and you'll see it'll become more clear. So this is going to be, we plug in, sorry about that, this is going to be 2 squared times 2.5, and then it'll be plus a times 2 plus b times 2.5, and this is equal to 0 because that's what the original function is. And this comes out to be 4a plus 5b plus 20 is equal to 0. So reminder that I said that in order for an inflection point to occur at this point, we know that the second derivative has to equal 0. And we're going to be looking at where the numerator equals 0, so 2ax. And we have values of x and y, so we can plug those in. So it'll be 2a times 2, and then this will be times 3b minus 2 squared. And this we're solving for where this equals 0, because that's where the inflection point is. And so what this comes out to be is 4a, 3b minus 4. And so the values in which this gives us 0 are a equals 0, because if you plug in 0, well, we get 0. And if you plug in for b, you plug in 4/3, you also get 0. So these aren't actually the points. These aren't the actual numbers for our function, but we can use these numbers a and b to figure out the real a for the a and b's that we are looking for. And that's why we're using this function to plug it in. So now that we have a's and b's, we can actually go ahead and plug those in and solve for our each individual a's and b's. So for the first one, so I'm going to put it in red, we're going to use a equals 0. So that means it's going to be, to make this more clear, I'm going to write this out. So it'll be 4 times 0 plus 5b, which we are not substituting, and then plus 20. This is all equal to 0. You solve for b, you get b is equal to negative 4. And now if I do it for b is equal to 4/3, what's going to happen is going to be 4a plus 5 times 4/3 plus 20 equals 0. And this will come out to be a equals negative 20 third. And those are our two, sorry, this is not clear, negative 20 third, and b equals negative 4. These are our actual a's and b's of our function. And that's it.